Hello and welcome. In this video, we're going to be discussing modeling concrete ramps, specifically using the spiral beam tool. We'll also discuss some of the extras that go with it, such as an outside and interior cylindrical wall. So without further ado, let's go ahead and begin. To model concrete ramps, we're going to want to use the spiral beam tool found on the concrete ribbon under the beam dropdown. If you hover over the tool, it'll give you a nice little tool tip on how to go ahead and input this. Also, you can hit Control F1 to open up the TUA for the page on this tool that provides maybe a little bit more detail. If we activate it, however, we can also come over to the instructor, and you can see how the tool is demonstrated to be put in by picking its outside extents and then its center point. You also can click a third point if you need to do a different center axis that's off, not perpendicular to your plane, which is a third point, but that's not required. So now having saw this here, let's go ahead, open up our properties pane, and just place ourselves a spiral ramp. Now, one thing though that I find working with round objects, whether it's cylinders like shield walls or ramp walls or anything like that, I find that, just dealing with a square grid can sometimes be counterintuitive. Now, you can have multiple grids in a model, and if you go to the edit ribbon, you can always drop in a radial grid. We do have a default one here, and I have one that I've already kind of done up in advance. I don't have any labels on this. It's not really important to me. This is a temporary. If your ramp actually has its own grid system, you may want to take a little more time to populate it. But I do strongly recommend, even if you have a rectangular grid already in place for your project, that you add your radial one. I like to do increments of 15 degrees on the azimuth. That way I have a lot of snapping points, but it may not be necessary for you. So if this looks a little dense, no big deal. I just like to kind of encompass and things I might need since I'm doing this a little bit more on the fly. But now that I have that in place, we can either keep or get rid of our rectangular grid, which I will delete mine for clarity purposes and redraw my view. Now, back to what we were saying, concrete ribbon, beam drop down, spiral beam, start from the outside extents, then click the middle mouse wheel. That's going to go ahead and place the ramp for me. Now, whenever I'm modeling anything that is cylindrical or round or anything like that, I do, like I said, like to use these azimuths, and I also model on the cardinal degree. So either 0, 90, 180, 0, 90, 180, or 270. And that way I just model here and then rotate into place, whatever degree it may be, either a nice even one or, fractions or decimal points of a degree. It's a lot easier to get something right and correct on a even plane and then put it into place. So that's why I chose those clicking points there. Now that I have the ramp here, we just need to modify its properties. We could have done this before we placed it, but for demonstration purposes, I'll go ahead and change this to ramp. I will give it a thickness of 6 inches, and we will go, we'll say a 6 foot in the thickness. That'll just kind of spread it out a little bit, which aligns really nicely with the grid I've already put together. Now, you can control a bit of the position of your ramp here, so we have some options. The typical position fields do apply: left, right, middle, on plane, so you're clicking insertion points. Where does the ramp or beam sit on either side or in the middle of that? We also can do top for the rotation, or we can choose, say, back or below, and it's going to give us the orientation of the profile. So we can actually use our pick points or copy a portion of our ramp and then make it into a wall if we wanted to. That's at least one method. Let's go back to top. The other things that we can control are both the rise, overall rise of our ramp, as well as the degree of rotation. So here you can do anything from 15 degrees and all the way to 360 or beyond. Now, notice though, that as we're applying these changes in rotation and revolutions around the center axis, we are not getting any change in depth of height, right? The total rise. That's because it's a specified value here, so you will need to adjust this depending on your project parameters. If you have several revolutions around a center structure, such as a cylindrical foundation or wall, you're going to go ahead and need to adjust that to be appropriate. So coordinate that with your project elevations. The other thing I'll say here too is if this were for a parking garage and you had a landing or a floor at every 15 feet or 20 feet or so, I would only model that segment of the spiral. And if there's a flat landing there that it ties into, then put that into place and model the next segment. But if need be, you can go continuous as we're showing here on screen. I think for our demonstration, though, we'll keep things simple, just to 270. I do like the 6-foot rise, but we'll change it to 10 just to give us some lift there. And there we are. And that's pretty much all there is to controlling or adjusting these. Obviously, you have the various different types of attributes that you can apply to it, and it comes in as an IFC beam. But I believe there is also ramp. You may want to change it to that as well if you're exporting to Trimble connector IFCs. I think with this now in place, we can talk about just a couple of other small particulars and things that you may want to take care of when doing ramps in general. Again, whether this is pedestrian or vehicle, you'll probably have some sort of center structure. You can use the column tool to place an object there and control its overall height and depth straight from the properties pane or the contextual menu. We can always do 5 foot. And then we can adjust its profile. We can, from the profile catalog, if you want a complete solid fill, the D or RB profiles are perfectly accurate. Otherwise, a hollow circular section may be more interesting or easy to use. I usually use the PD or EDP profiles and just provide a value of the diameter, and it says inches, but you can type it in. So if we had, let's see, we have 14 feet here. Yes. So we can go 28 feet. We'll give the wall thickness, let's go be robust, 12 inches. Apply, okay, and then modify. That's going to give me a wall there. Again, we can always bump this up to and change the class if you want it to mimic more of some of the wall presets. There you are. Same thing for the exterior if we wanted to do that. In fact, I'd probably just use the spiral beam tool again, changing the profile. We'll say that it's I don't know, 42 inches tall and 8 inches thick. And then I'll just come in and click the same 2 points, and middle mouse click, give it a second to think. All right, that pops the wall in for me. Oh, adjust its position. One thing too, make sure that you're modeling not only the width of your walk or your drive aisle, but also the thickness that may be required for the wall. Now, if the exterior wall goes all the way down to the ground, you can certainly extend it down that way as well. You may want to use the cylinder and then use a cut plane or cut part, but I would, in this case, just augment the ramp to be slightly bit wider. So like we did 8 inches, so. And then make sure to drag that out and add that 8 inches outside. And then we can change from left to right on our wall. Cool. Now, one thing about the ramps and things is you'll notice that we get a pitch at the end face or plane of our objects, right? We can use some of the edit functions to kind of fit those ends. And the fit part end is a great way to do that. We can click, pick our flush, and then it's going to fit that up true for us. So that's nice and flush. If we go to plan view and do it again for the wall, we'll pick the object, pick our 2 points, and then let Tekla go ahead and fit that to that plane we've just defined by clicking 2 points, and that'll kind of flatten things up for us. You can do the same for the top of the wall too, especially if you have to tie in to a landing or slab or anything like that. Just be cognizant of where you're picking. Sometimes it can be a little tricky choosing from a plan view, so just verify what you're doing there, but that should be able to even things up.
Now keep in mind, the one thing about fitting ends here is if we were to now increase the rotation, because that's in place, it may block it from happening, okay? I've seen it happen before. It doesn't happen consistently, but I just want you to be aware that if you fit your end and then try to grow this or extend it and you don't see the results being applied, it's probably because of that. I think it's more to do with the line cut tool than the fit part end, but I figure I'd bring it up anyways. And so you can always delete that object. And if you don't see it, you can always turn it on by turning on fittings in your view.
This concludes our video. Thank you for watching. Want to learn more about this topic or how to get started with Tekla Structures? Just check out the video's description for links to our user assistance page and user resources guide.